Okay, you've got this automotive electronics test 12 here. A photocell uses light to change resistance. Is that true or is that false? You see this thing here? This is a photocell. You can hook a meter up to each one of these little legs on this photocell, and you'll be reading a particular resistance. And if you cover that up so it can't see any light, that resistance will change. That's a photocell. They use photocells in all kinds of things now. And so the electronics are reading that resistance, and that's what gives you, that's what a photocell is. Fiber optics are used in areas where bulbs would be inaccessible for service, and that's true too. I thought it was really interesting. I was working on an international truck back in, we used to have at our company when I was working in Texas down there, and every knob on the dash had a little lit up words above it telling you what it did, and every knob on that dash was lit up by a single light bulb. There was a little light bulb that was in this little thing. It looked like a flying saucer, and it had these optic fibers going out to all of those lights under there. It's a cool looking thing. I mean, good idea. Use that one bulb that lights up everything. You know, you'd have to go in there and change them. A potentiometer is commonly used as a sensitivity control. That would be true. You also use it in a situation like in your, where you use it for your dash lights on most cars now, because you're not actually feeding power to the dash lights through the, you know, through that little thing you roll with your thumb. Also your, and there's Kathy Jo. You're 2 hours late.
I know.
Not really. You guys have been taking a while to get here nowadays. What's up with that? Whenever, well, I guess when I call, they say, oh, they're just going over to the school. We don't need to be in a hurry for that.
No. Usually when you call, we've got a few others. See, I don't know why.
So what you're saying is my timing is makes it.
Yes, your timing.
Yeah, okay. Here you go. And hang on to that till we get back to the shop.
That.
Well, she's the one that's going to put it back in there. Lay that out there on that cart by that Ford 500. But she can hold on to that. All right. Let's see. But anyway, potentiometer is also used for your blower speeds and that kind of thing. If the parking brake is applied while the engine's running, the daytime running light feature is turned off. What do you think about that?
Well,
That depends on the vehicle. That's true, actually. Like on that Chevrolet pickup that I just talked about over there, and on that green GMC we got. If you back it out and you got it in drive, you're sitting there with your foot on the brake, and it's in drive, it'll turn on those lights after just a little time goes by, but it turns on the daytime running lights, because the little optic, sensor in there, like I just showed you a minute ago, actually, there's got some electronics in there that turns off the headlights and turns on these little lights underneath the headlights. It's got them smaller bulbs in there. But if you mash the park brake, those lights go off. They don't have any reason to be on if you're parked, because they're running lights, right? The adaptive brake light system selects different levels of illumination of the brake lights depending on conditions. Now that's cool, and that is, what else can you think of that does that? Whenever the light changes, the ambient light changes, the amount of illumination changes. What can you think of? You don't need as much when it's at night, do you?
Talking about the headlights?
No, I'm talking about on anything. What about your cell phone? What about your TV? Nowadays your flat panel TVs do that. They'll be brighter when the room's more lit up. If you see me and my wife sometimes we watch TV whenever it starts to get dark outside, and you'll see the change in the light on, the backlight on the TV. It's an energy saving thing. Technician A says, when a fiber optic indicator is not operating, the cause could be a bend in the cable. Technician B says, the cause could be the light source not operating. And that would be B on that one. Technician A says solid state circuitry is used in headlamp dimming systems to control beam switching. Technician B says headlamp dimming systems use mechanical relays to control beam switching. Both people are right about that. I had a 67 Chrysler New Yorker. Had something on the dash. It looked like a little ray gun that was pointing forward. And whenever you were driving down the road, if that little ray gun saw a car's headlights coming, it would dim your headlights for you. Dink. That was in 1967. Of course, that car also had tilt and telescope steering wheel. It had another switch in the floor next to the dimmer switch you could hit, and the radio would search for stations. It was a cool car, but they did a lot of that stuff, and it kind of went away after a while, but they got other stuff they put back in there. Long and short of it is, I was driving that thing one night, left the filling station where I worked, and I was heading down Dale County 1, and there was this big truck coming. And this was, you know, this was in probably 1974 or 5, you know. So the car was about 6 or 7 years old. But anyway, I'm driving down there, and this big truck was coming, and I don't know if it confused that thing or not, but it brightened dimmed the headlights about 5 times, and then it turned them off with this big truck coming, wah, you know. So I unplugged that sucker, and I had just plain old headlights after that. It scared the daylights out of me. I thought I was going to get run over. Richard was a good old boy, you know. All right, so Technician A says fiber optics. Wait a minute. Where did I go? Where are we at?
8.
Okay, Technician A says fiber optics provide illumination of several objects by a single light source, which is what I was talking about. Technician B says light rays travel through the plastic strands by means of external reflections. That's A only. Technician A says to determine the illumination level of the instrument panel lights, the body computer uses inputs from the panel dimming control and photocell. That sound right to you? Sounds right to me. Everybody like that? You gonna be able to remember this? Tell me off the top of your head? Okay. Technician B says using the body computer to control many of the lighting circuits reduces the amount of wiring required.
Both of those guys.
That's C. Yep. Okay. The headlamp doors of a vehicle equipped with computer-controlled concealed headlamps will open but will not close. Technician A says the actuator motor may have an open winding. Technician B says the motor brushes may be faulty. That's D. You know, there's a bunch of different ways those concealed headlamps work. I had a 69 LTD with concealed headlights on it, and they were vacuum operated. And but this one guy had a 69 Cougar, and he said something went wrong with his while he was driving down a dirt road, and the concealed headlight doors closed while he had the headlights on. Well, you can't see you then, you know. Scared daylights out of him. Now, what if you were going to design a system like that was going to operate on vacuum, would you make it so that they had to have vacuum applied to open, or where they have vacuum applied to close? What's a smart way?
Probably open.
You want to have to apply vacuum to open them, but whenever you're really getting on it, if your engine vacuum drops off and your little vacuum reservoir is leaking a little bit, won't your headlights close up when you're getting on it? Might be a good way to slow somebody down, isn't it? Actually, they do it typically where if something happens to the vacuum system, on my 69 LTD, the lights would open if you disconnected the vacuum from it. You know, that's what do. The headlamp doors of a vehicle equipped with a computer-controlled concealed headlamp. Wait a minute, that ain't right. That's the one I just did. Sorry. Technician A says fiber optics is the transmission of light through several plastic strands that are sheathed by a polymer. Technician B says fiber optics cannot be used for automotive applications. Good grief, you know we can. So that's going to be an A only. Now, which of the following is true of an LED? It produces red, green, or yellow light. It contains an anode. It requires an external light source. What? That's A only. Yeah. It doesn't contain an anode, you know. One of your leads is called the anode, and the other one's called a cathode, but, you know. A lamp outage module provides power to which lights?
Stoplights.
Stoplights, typically, yeah. And basically, it's measuring voltage drop across some resistors, and it's reading it that way. You know, Ford used to have resistor wires. You know, when they had a little nondescript automobile down there with little LEDs behind it to tell you which lights were out, it would use resistor wires on the way back here. Anybody put a trailer tow, you know, a trailer plug on there, it would burn those wires up. I had to fix one of those one time. Let me see. Technician A says the light should turn off after the selected amount of time delay when a bright light is shown into the photocell. Now, it's not going to happen instantaneously. That's what you got to be used to. If you're going to check that, you shine that light in there and you wait a little bit, 45 seconds or something. It's going to take a little while. Technician B says the headlight should turn on within 10 seconds when the photocell is covered and ignition switch is in the run position. That's going to be C there. Some of these little boxes that's got that photocell in them, on some of the Ford pickups, used to have a little, and they didn't tell you about this in the shop manual, but you look in there and they had a little trim screw in there, a little potentiometer. You go through a hole and you can turn it this way and that to make it more sensitive, which is pretty cool. If the customer was complaining, you knew how to make an adjustment on that, you know. All of the following are precautions to prevent static electricity damage except A, ground the cart into a known good ground before opening. B, open the package only when ready to install the component. C, wipe the terminals clean before installing the component. Or D, touch a known good ground before opening the package. Well, wipe the terminals clean before installing a component is the one that's not going to help with static electricity damage. Now, you remember what I told you? Whenever you shuffle across the floor and you reach out to touch something and it goes pop, you know what I'm talking about? And, you know, it jumps out of your finger. Yeah, that's from 8 to 25,000 volts is coming out of your finger when that happens. That's why it bites as bad as it does. I feel like a spark plug, almost. But what the deal is, you will destroy electronics on that. And I will talk to her later on. I'm not going to talk to her right now. All right, let me see. Where are we at here? The low beam headlamps of a vehicle equipped with Twilight Sentinel automatic headlamp system are inoperative. The high beams happen to be working correctly. A voltmeter connected across the low beam contacts of the dimmer switch indicates 12 volts when the low beams are turned on. Technician A says the circuit from the Sentinel amplifier to the dimmer switch is okay. Technician B says the dimmer switch is faulty. Who is correct? Who knows? You understand what they're saying? I will tell you this, when they talk about this stuff without showing you a picture, it's useless, you know, because you lose track of what they're talking about. All right, this is the deal. All right, watch this. I've got two different windings. This middle one is ground. This one here is bright. This one here is dim. Got that? All right, so you got a connector here that you can unplug. Now let's say that you took your meter and you went from here to here, right? Okay, when the dim lights are supposed to be burning, you're getting 12 volts right here. Shouldn't you get 12 volts there?
Yeah.
What's likely to be the problem if you're reading 12 volts on both of those lights?
I mean, you should. I mean, it's a ground there, so I mean, so you can't read that 12. I mean, you should.
Well, you
only get
can
12.
between 12 volts and the one that's feeding power to it. The light's not burning, but you got 12 volts there. What in the sound hell does that mean to me? That means the bulb blown, right? You remember how y'all fought with that one back there, and all that neon,
I don't even want to talk about
and
it.
both the bulbs were blown. What happened was, that was silly. I gave them guys. That guy says, I need some more bulbs for this thing, you know. And so I said, well, get the bulbs off that harness over there that came out of that Lincoln that we changed the headlights on. So they got bulbs that they put back there, and they got two bad bulbs, and they put them back there, and they kept on looking. And she,
Before he had me rip that car apart, let me check them bulbs. He's
Yeah.
like, no, that's not it. They're
yeah.
fine.
Well, I said, well, they already put bulbs in there. Now, this is a lesson that you learn. It doesn't matter who has said what. You check for yourself.
Yes, I know that now.
You know that now. I mean, because you can get let off down Robin Hood's barn on that thing.
I remember, what's the guy name? He got me and Willie like that one time on
Adam?
Yeah.
Yeah.
Yeah, on that Crown Vic.
Yep. Well, he cut a wire
Yeah, he
too.
did cut a
Yeah.
wire.
Yeah. All right, Adam, when he was here. Let me see. So number 16 is going to be a C right there. You know, basically. But is the dimmer switch faulty? See, they're claiming it's both A and B. I don't like that. Just put that so she won't mark it wrong. Put C. And you got what I'm talking about right here when I do the picture. A vehicle equipped with a BCM has two fault codes stored in memory. B1445 and B1446. Those are body codes. After the codes are cleared, the vehicle is driven 2 blocks, and then the BCM is retested for fault codes. This time only code B1446 is stored in memory. Which of the following statements are true? A, B1445 is a current code and B1446 is a history code. B, B1446 is a soft code and B1445 is a hard code. C, B1445 is a history code and B1446 is a current code. So you can get your head all lost in these. And D, B1446 is a hard code and B1445 is a current code. So well, the one that comes back is the one that's a hard code. right? That's going to be the current code, basically, is what it is. So it's going to be C. The interior lights of a vehicle equipped with illuminated entry system stay on even after the ignition switch is on. You know how when you get in there and before you put your key in the ignition, all the lights in the side are on, and then they fade out slowly after a time. But when you turn on the key, they're supposed to go off right away. After a short interval, they turn off. Technician A says the input signal from the ignition switch may be open. Technician B says the entry module may be faulty. Who's correct about that? And that is C, both A and B. And see, because it's got to know when you turn on the key. If it doesn't know when you turn on the key, it ain't gonna turn off the lights. That's how you got to see what it's thinking about. A lamp outage warning system is indicating a lamp failure. All the vehicle lamps are working, but one of them, the left rear tail light, appears to be dimmer than the rest. Technician A says the light bulb may be mismatched. Technician B says excessive circuit resistance may exist in the right rear tail light circuit, and that would be A. Let's see. I'm just really not too happy with that answer either. Some of these test questions are just irritating to me. All the vehicles are working, but one of them, the left rear tail light, appears to be dimmer than the rest. Can't we have a excessive resistance in there? Don't you think that would cause that? What do you think? Couldn't you have excessive resistance making that thing be dim? I mean, hadn't you seen that? I mean, dimmer light because of excessive resistance, voltage drop. I mean, let's see that the people that wrote the test claim that A is the only one that's right. That's the one you need to put, but I don't like that. Technician A says the photocell should be replaced if the lights don't turn on within 60 seconds when the resistance assembly switch is in the off position and the ignition switch is in run. Technician B says the photocell should be replaced if the lights turn off within 60 seconds after the resistance assembly switch is turned on. Who's correct? That's not, neither one of those knotheads are right about that. Okay.